Well, hi, good morning. Thank you for joining me in my shop. Today is October 8th. And so yesterday I took a shot at making this radio work. I really had my fingers crossed on it, and unfortunately it didn't work out. So if you watch the video, you know what I did. I tried to supply it with a simple 12 volt supply rather than the internal power supply that I think is in trouble. And no, it didn't really work out. In the meantime, of course, I've been reading up on this radio quite a bit. There's a lot written about it, and a lot of it is very negative, I have to say. In particular, a radio like this, having it's not in working condition right now. Bringing it up to working condition is probably a monstrous task, and I don't really think I'm going to get very far into this. Frankly, this is one radio I really don't have much hope for in my hands. I'm not that experienced with transistorized circuits. Not that that's really a limiting factor, but it definitely makes things more difficult. And how many transistors are in here? One heck of a lot. If you think about a tube radio, what's it got? A big communications tube radio might have 10, 12, maybe even as many as 20 vacuum tubes in it. Many of them kind of doing the same thing over and over, amplifying stages and that. This guy, how many transistors are in here? I don't know. 30, 40 transistors inside this thing. That's one thing about transistors. You can't generate as much gain. And this is a very early transistorized machine. And so these transistors, the ones that are in here, are probably original, probably from the 1950s. And they're probably bad, unfortunately. A lot of these are going to be germanium. All these tall ones here are probably germanium transistors. And if it's blowing, how am I going to get a replacement for that? The fact is I have thousands of vintage transistors. Thousands of them. Poorly organized, just kind of stored away. Many of them are germanium, but what are the chances that they're going to match the germanium that's in here? My understanding, and I don't have good experience with this, is to a large degree, unlike vacuum tubes, transistors are kind of similar. There's a lot of similarity in them. You don't necessarily have to put exactly the same thing back in if you pull one out, but I don't know about that. But I mean, that's looking way down the road. That's looking too far down the road, Jim. It's depressing. Don't look down that road. Let's look at a shorter road. So there's no audio output from here at all. There's nothing. No hiss, no click, no pop, no nothing whatsoever comes out of the speaker or the headphones. And that really suggests that the final audio stage is in trouble. And guessing it's from these three. There's three larger transistors here, probably the output transistors, almost undoubtedly. Three of them. It's just driving a small speaker. But so what can I do here? So I can power this thing up, and then I can snoop around and try to see how much of it is working, if any of it is working. How would I snoop around? Voltmeter, not terribly helpful in this case. Signal interception using either a signal tracer or just using my SDR with a loop of wire and just hanging it around here and seeing what kind of signals are there. This radio, I believe, is a triple conversion, at least on some bands. I think it's a triple conversion radio, and I think that would mean it has 3 local oscillators in it, every one of which, or any one of which, could be picked up with the SDR and the VFO also. So yeah, I think that's my only option here. I can do some voltage testing through this fantastic terminal back here and see what voltages are further in the radio, and that's probably a very, very good thing to do too. Of course, I don't really know. Well, I don't know enough about this to say any more about it. Okay, let's get the radio switched on, and I think I think we'll do the SDR thing, and just because that's easy, and we'll see what we can find. Now look at the top of this radio. Man, it's all metal. I mean, the whole thing is metal covered everywhere. Is there going to be any signals up here? I guess maybe near the tuning capacitor that's sticking out here. I don't know. We'll find out. We'll snoop around. Yeah, we'll just snoop around and see what we can see. You can see my mouse isn't working right. Very annoying. Okay, so if you're hearing a hiss, that's the cooling fan in my power supply going over there. Unfortunately, so another thing about this is they socketed every transistor. And they just vacuum tubes go in sockets. I guess transistors do too. That's what they were thinking. So like if you look at this part of the radio, you can just see all the sockets and transistors in them. Well, every one of those has a chance of a bad connection in that socket. Sort of a mechanical kind of problem. Oh my God, there's just so many ways for this thing to go wrong. It's kind of surprising it ever worked. Okay, so I've got voltage on the end of this clip. I'm going to stick it on the supply terminal here and turn the radio on. I heard a click come out of the speaker when I did that. What's that tell you? That says something. Just trying to make sure I don't get a short over here. Okay. Are you working this morning? I mean, there's a chance. There's a chance. Jim, do you have an antenna connected? Yes, but it's not switched on down here. But look, no, there's no way this is working. Okay, what we want to do is sniff out some signals, and I'm not even familiar enough with the radio to know what signals to look for. There's a 455 in there. I think the first IF is 455. I think. So it's going to be, I don't know what I'm talking about. Depends what band you're on. Control, I don't even know. Local oscillator, what's happening. Let's do this. We will stick this. There's a band here, 0 to 1.5. It actually says 0 to 1.5. So now we're supposed to turn this. Did we see something? So here's 1. So that would be middle of the broadcast band. That would be just fine. So I'm going to set this. I can see the light here. See, like it's dull over a long range. I don't know. This is just craziness. Okay, we're going to set this this way. Way down here to, so this would be 1,000,000 plus 70. There's a signal at 1010. yeah, hey, there it is. We'll pick it up, and then we got this pre-selector we need to tune also to roughly the right area, which would be right in here. I sure don't hear anything, of course. Now we're going to get the SDR happening here. I've got to stop for a minute. I didn't get it ready. Got to get it ready. Okay, so you can see the SDR on the screen, obviously. And this is the SDR pickup coil here, which I'm going to fool with and prove that this is working. Okay, this is just the antenna lead to my SDR. So the radio's tuned to, I believe, 1010 AM radio. That means the oscillator should be somewhere around 450 above that. So that would be 1450, 1460, somewhere around there. And I'm going to stick the red line here at that location. 1460 would be right there. So we're looking for something to pop up in this area here as I wave this around on the back of the radio. The heavily metallized back of the radio. Well, there's something popping up at 400. Something popping up at around 1,000. There's that thing at 500 again. You know, there could be a crystal in here that's running at 500. So there is a little bit popping up. If you look at the red line, just to the left of it, you'll see something that has popped up there. And now I'm going to tune the radio a bit and see if it moves around. It does not move. Nothing is moving. Something like the local oscillator, if it's on here, it should be moving around. And I'll go over here. And way over here. The patient appears to be dead. I'm not seeing anything. Anybody see anything in here? 500 signal comes up pretty clearly. Up in this area here. Whoa! I found a whole bunch of stuff. A whole bunch of stuff there. See this thing just at 950. What is that? Because that goes up too when I stick this in here. 950. Is there anything moving during the tuning process? No, nothing moving at all. Well, where this is one band, where we're testing. I'll go near the capacitor over here. This capacitor is not turning at all. What is that? That is the... what is that? Synthesizer tuning. Well, I haven't been fiddling with that. Well, this is a little interesting now. Now watch around the 500. Yeah, see? See how nothing happens? You got the light going on. Oh! Wow, what's happening there? So I noticed the light came on, and what is that? We still don't hear anything. You know, we can kind of hear this on the SDR. If I put the red line in this, what is this? Let's listen. No real surprise it sounds like that. Just to make sure you can see my hand here. Otherwise it becomes kind of mysterious. Oh, there goes the oscillator. You see the gibberish went away. You know what? I think I read about this. I think I might have read about this. That, and it could be totally wrong in what I'm going to say, but the thing is hunting across the crystal frequency. Forget what I'm saying. It's stupid. But, well, we can certainly see there's a lock-in, a powerful lock-in. The 500K is important. That's the range of the big knob here. And so it's multiples of this 500K that are stepping the radio up through the different bands. So we're seeing the bottom, the 500. Isn't this supposed to lock in at higher and higher frequencies? Not just 500. So we would see it every 500. We would see it at 1 million again. I didn't see anything at 1 million. Maybe something happened at 1 million. It's not. There it goes. Oh, I heard a little click in here. Heard a little click. Didn't hear it that time. I don't know what I heard. What would click? There's nothing to click in here. So looking at the 1 million and the 1500. Well, interesting. Way up on the high part of the SDR, up in here, you can see stuff come and go. So if we put this to oscillate, see the light go out. Keep it oscillating, watching the red light, the red light over here. Is there something wrong with this video? It's way behind. Like, I move my hand and it takes like 2 seconds for me to see it. Maybe I gotta stop and start again. Okay, we're trying to make the... Oh, I'm at the end of the run here. What's going on? No, I'm not. Okay, light is on. Light goes off. The light is only going on and off at the... Like this knob turns a lot. I mean, you can go a long way. So the capacitor back here barely moving. The one I'm holding the coil near is barely moving. You can see this. Here's the capacitor right here. In fact, let me stick this in here. I don't have to hold it anymore. Get in there. Okay, it's not going to stay, is it? Yeah, that's going to stay. Okay. Let's figure this guy out now. The pre-select tune shouldn't do anything to anything, and it does nothing to nothing. Synthesizer tune. The capacitor is moving back there. Here's the 0.5 indicator. But the oscillator appears to be staying on. No point there. So let's... Oh, okay. Light came on. The light comes on, it indicates the condition we see on the SDR now. I'm watching the light. There, the light just popped off. What happened? We but the 500K didn't reappear. Let's keep going here, just see what happens. Oh. That's the end of the run there. Phase lock is lit. There's a line coming by here. It's indicating end of the road. Back, light goes out. Light comes on. Light goes out. There's no question that it has to do with that. But where's the oscillator? Is it off to the left on the screen? Way down here? No. Is it way up here somewhere? Like, is this it here? So the problem with the SDR is it has a lot of anomalistic stuff on it. Where am I going here? Okay, that's a totally closed capacitor. We'll go to the... watching the window here too. So there's a spot. Where's the action? Where's the... I got this thing slid way over here. Go back here again. Very strange. Very odd pattern on that screen, but okay, what am I doing? Losing control. We want to get the oscillator oscillating. Oh! Now that just popped up. This is at well, 54 kilohertz according to this. Now there's a 60 kilohertz stage in here, which I don't think would be engaged when I'm on this band. Oh, so much fun. Synthesizer tuning. 60,000 has stayed in. The light has come on. The light is on. right past some key point here. Oh, did the light go off? The light went off. Let's go back. Light is on. So this time, this is not 500K exactly. This is 445. Wasn't it exactly 500 before? 445. That's a funny number. It's close to 455. Could be a signal in the IF. Let's tune and see if it comes and goes. No. 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 Okay, continuing on here the whole way. Light is out, light is staying out for a long range. And the light comes on. Oh, and now this stuff is up at a higher frequency. The junk. Okay, we'll keep going. Keep going. The junk is moving to the oh, a new one. So we're coming in towards 1. And interestingly enough, that line popped up very close to 1 megahertz. And so that would put the local oscillator just above. I'm guessing 455 up. So it'd be right up in this area, but we don't see anything. Okay, that's interesting. So this synthesizer appears now to be working. So it's synthesizing 1 megahertz, and then I believe it's somehow adding this on top. I don't know how exactly. Okay, let's keep going up. Is there another stop? Maybe 1.5 up here. Let's keep going up. So we're still oscillating nicely at around a megahertz, getting stronger if anything, and I reached the end of the road here. Phase lock light stayed low, never goes out, stayed low. And then we lose it, and the light comes on. And then we get it. And when we get it, it seems to stick right there. Let's go to the next band up. Okay, so the next band up is 1.5 to 4 megahertz. 1.5 to 4 megahertz. So 1.5 is right here, and if we assume the local oscillator is still supposed to be running 455 above, then it would be in this area. Here's something way over here. Is that the local oscillator? We shall say no to that. Okay, so something to do with this. Where would the nonsense show up now? Down. So we got 3.5 coming into the screen here, and see, there's something going on. The 3.5, if that's what's being triggered, it's off the screen here. So we'll slide this over. Okay, 3.5 is here. We have pretty strong signal there. Is that the one? Is that it? The light is out, so this would suggest the light is low. This would suggest the synthesizer oscillator is operating somewhere, somehow. And it's come and go. The band switch could be dirty. Oh, look at that, eh? Could just be a dirty band switch here. What's happening there? This shouldn't matter. Well, 3.5. Nothing showed. Let's go back down to the lower end of this thing and just see if by some chance it's still popping up here. So the light is low, so we think it's on. Make the light go high. The light does not want to go high. There, it's high. They won't stay high. Oh, there we are. Any weirdness? I don't see any weirdness. Weirdness on the SDR? Anybody know what's going on yet? Anybody have a clue? Anybody have a clue? Here's some interesting stuff. What's all this? A local oscillator. Certainly is coming from the radio. Oh, looky that. Looky that. Okay. Dirty band switch. Now we'll try this again. Make the light go out and see if this thing just turns into a single. There it is. There it is, and all his brothers showed up too. So very odd here. So in this position, light is low. We have a strong signal here at 3, and you know what? 3 point. Come on, mouse. My mouse sticks all the time here. 3.450. I think there's another crystal in there like that. Right? It's not this. You never see the VFO operate. But we're certainly seeing this thing do its trick. Let's go down. Wow, a lot of weird stuff. We go up. This is the 3. This is supposed to be at 3. Well, I don't know where it's supposed to be actually. 3.5. The light is out. So inconsistent. What happened to it? What was going on there? Very inconsistent behavior of this thing. Again, this guy. Oh my gosh, it could just be this band switch. I can get all kinds of stuff to happen here. And we've had the volume up the whole time, never heard a thing. Let's go to the next band. This is 4 megahertz to 10. 4 to 10. So we'll go up to 4. First of all, anything moving there? Nope. Light is out. Right on 9. 9. I gotta go up to 9. Let's go up to 9 here. Go up to 9. So one of the things about doing this kind of stuff, it's just fishing around. Just keeps me interested in the radio, and when I go to read up on these things will lock in a lot better in my head, at least for a minute before they leak out the other side. So 9, we're tuned to 9150. That doesn't matter. And I don't know anymore. Is the 455 still valid here? So just using this now. You have no idea where this is tuned. Like, this has got a long range on it. Well, yes, you do. You do on this, Jim. I'm a new operator. What can I say? So this seems pretty good. The 9 comes up, and the light goes out. The light goes out slowly. So indications are there's something. Let's go up and look at 9. 9's right here. There's nothing there. Nothing there. Well, it's possible the signal is in a different part of the radio now, and where I've got the pickup coil is no longer in the sensitive area for this particular signal. Why do I say that? Well, what else can I say? Say something else. So we've never seen the VFO at all in this radio. Let's go another band up. So we're on the 10 band, 18.5. You can see that. I turned this too fast. Maybe that's what's going on. So there seems to be a phase lock occurring in here. So we would think 18.5 is locked in now. Screen, I don't see anything. That's because I'm on 12. I should be up on 18 now. Okay, we'll take a look this way. We'll take a look the other way. Local oscillator could be, 4 megacycles away. I don't know. I don't know what they're doing enough yet. So if we look at 18 though, so 18.5 is right here. The light is down. Oh, yeah, something popping in, popping out. Is it matching with the light? Yeah, more or less matches with the action of the light. Okay, so I think what we're going to do now, we're going to change our attention and try to find some audio to hear in this radio. How the heck am I going to do that? Check to make sure the speaker is actually connected, which it certainly is. So that's not an element of this. We will do this by trying to listen to the output transistors. Yeah. So these transistors are not isolated from... hey, there's something interesting here. Something a little bit interesting here. If you look at the 3 output transistors, 2 of them on the right, the AD149s, they look newer than that other one on the left. Huh. Probably means nothing at all. It's probably just a different kind of metal. It's aged differently. That's what we need to look at. We need to look at the bottom of those guys. Okay, let's cut the power off here. Okay, that's easy. I can turn this off here. We don't need to listen to it. Although it's going to give its warning thing in a moment. We want to try and flip this way. And it should go okay. This is one heavy radio, boy. For a transistor radio, you'd never imagine that this has got transistors in it. Okay, here we go. Wow. There we are. Sit like that. Oh. Even though I warned you that my power supply was going to make that funny chirpy sound, it still scared me. Well, we want to look at the bottom of those transistors. I think it's right here. 1, 2. No, those aren't transistors. Where'd the transistors go? The transistors were... Anybody see them? This is them here, I think, under here. Right in here. Let me reach up underneath. Yeah, definitely. Do I feel something hot here? No, my imagination. Nothing hot. That's another thing I could do. Just get my heat thing out and look for something that's overheated. So, wow. Yeah, sure. Test those. Sure. In the book, in the manual, it warns, do not try to test the capacitors with your ohm meter. It suggests the ohm meters, some of them have too much voltage in the test leads during an ohm resistance test, and they will damage the transistors in here. What it suggests is operate the set and then check the voltages on the transformers to see it, on the transistors to see if they're correct. That's the approach. Now I do have a device here that will test transistors. This very nifty little guy here. 3 leads meant for a transistor. You hook it up, give it a test. In the radio, these ones are not socketed. They are socketed. These are socketed also. We can pop those right out. Well, they could have a bad socket contact. So the depressing thing about this radio, and what I read about it last night, was I read a little dissertation by somebody who had acquired one of these very similar to me and just got one. And he worked away on it, changing out this, that, and the other thing. In the long run, he says he would have done much better had he just gone ahead and changed every electrolytic capacitor and every resistor in here right off the bat. It would have saved him time. Oh my God, that's a yeah, wow, that's just a huge amount of work. No, I'm much more inclined to find a little something wrong, fix it, and presto, she works again. That's my hope here. So a number of things we can do. One is we can listen for a signal. Oops. Well, I guess I better go answer my door. Okay, let's take a look at the schematic. This is the output area here, audio output area. This is the output transformer, and then this is the terminal block on the back of the radio where I have the speakers connected, and that's the phone jack there. So there is a ground connection. It's just worth noting. The one that says ground, it does have a ground. Okay, and 33 ohms sitting here. That's interesting. So we have two transistors appear to be in the push-pull configuration here, and they're fed from this transformer. This transformer gets its feed from this, well, they call it audio driver. Back further, the audio driver is getting its signal. Look at all these electrolytic capacitors here. Whew. Look at this one. This one's right in the signal path. That's surprising to me that they're used this way, but then, you know, I'm a tube guy, so I'm not looking at transistor circuits so much. Here's the volume control. Excellent. The volume control is easy to locate in a radio. You know where that is, and the wires are easily spotted. So we can get on, for instance, the output here, a 4.7K resistor, or spot this capacitor. We can sample the signal here. What's this audio input? J14, because that's also an output. Audio input. Why would you want to do that? Audio input ahead of the volume or after the volume control. J14, pin number 17, or position 17. We got to look at that. We got to take a look at that. Okay, it's a J14. That's that big jack on the back here. And he's saying number 17, audio input. But you can see it's also, you could also take the audio out. So if I check here for audio, we will know if there's any audio making it to the start of the audio stages. Very good. That's very good. 17. So if we look on the back here, spin it around. Here we are. Get this oriented right. So the bottom row pins, I think this is this way. And we would find, oh, there's a detector out also. Oh, that's good too. So looking here, we would find number 17. This one here, this top left corner. No, that's not right, is it? Very small numbers written there. 17 is in the middle, so it's this one. This is the audio one here. Audio input, or I can also drive audio in there and push it through the audio stages and find out. Hey, either way, this is a winner. Okay, gonna drink some coffee and then we're gonna attempt some of this stuff. Okay, and I think I'm ready for this test. So first of all, so what I'm going to be doing is I'm using this signal generator, which is producing a 1200 hertz signal at a very low level, and I'm going to feed that into this spot here. You can see a little wire sticking out here. All I got to do is just take this clip it on. We're feeding signal. Volume control is from the signal generator, not the radio itself. Ready to put on the power. Negative, positive. That was kind of clumsy, but I think the power is on. Is it on? How can we tell? Can't see anything from here. Hand me my mirror. There it is. Sometimes it's hard to see a mirror. I'm looking for some lights. No lights. No lights. How come? How come no lights? Did maybe I took the ground off too? And yes, I did. I took the ground off, so we'll put it back on. Okay, this time, here we go. Ooh. So I heard noise come out of the speaker. It works! And just to double check, yes, the light is on. The light is on the radio. So we'll now hook this up. And I guess we got to turn up the level here. See what we get out of it. Now, am I doing this right? No, I did something the other day in here, not on video, where I tested an amplifier and I tested it at 700 hertz, but in fact I was testing it at 700 kilohertz. It didn't work, by the way. So if I got this correct, so we're on the 10 kilohertz there, and that's a one, yeah, definitely, it's 1,000 hertz, but not much output. So we're going to raise the output, up, lots of output now. Do you hear a thing? I don't hear a thing. So this would suggest the audio circuits are not working. And now we can turn this from an input to an output. So I'll take this off. And I'm going to have to fiddle around a little bit here. And what we'll do is I'll hook this thing up to the audio system that you're listening to me on, and we'll listen together. Okay, I think we're ready. So what I've got here is this is now an input to the audio system you're listening to, and I'm just going to turn up the volume here. Just make sure. Only one channel. We need to flip it to both channels. A little loud. We're checking the ground. Yeah. Okay. So we're gonna turn this down. Get your ears blown off by some surprise. The volume on the front is now in control here. This is the volume control. And oh my gosh, this would be down, I think. So I think I've turned it down. Here we go. We're going on. Okay, turn up the volume on the sound panel. Turn up the volume on the radio. I hear nothing. Okay, I don't hear a thing. Yeah, it's definitely doing its thing there. So we have nothing going on here. Let's see if I can rotate this enough here. Keep getting into trouble. I think I'm going to get into trouble. It's probably good enough right there. Okay. Look at what we do up here. We could change bands. Did you hear that? You know what that was? I think that was the. Look at that. We've actually got sound coming out. But you know what? You don't hear this in the. Let's check the volume. Volume making no difference. Why would that be? Why would that be? Okay, so theoretically, the radio is now working on the 4 to 10 meter band, 4 to 10 megacycle band. Let's go up another chunk. we do have the antenna connected. I have the antenna switched on here, but not back yonder. So I've got to go turn on the antenna. I don't give this much hope, but I'm going to go do that. Switch on the antenna here. Okay, first of all, I'm going to turn on and off the antenna. And making no difference. Make sure the volume and the gain are up full, and the light is low. We're not getting anywhere here at all. What can we try next? Pumping a very powerful signal into the antenna input and trying to ram it through the radio, so to speak. That's actually a valid thing to try. Okay, I'm going to stop here for a moment and get that set up. Okay, I think we're ready for another test here. So I have the radio tuned to 8.5 here. The synthesizer is operating there. The this control has to be set too. So we're operating around 8.5. So it's about 8.5 here. And the volume and RF are up. We are on just regular AM here. Is there anything else that needs to be done? Don't think so. Okay, so we're going to hunt now. I think the radio is tuned to 8.5 megahertz. Now I've got this set at 8.5 right now. So let's go up and down there a little bit. Nothing. I'm going to go up in strength. So this is like the most powerful signal you would get off an antenna, something like that. And now we're going to go 10 times stronger than that. Let me check. Calibration here is not right. If I take it back, we had almost no signal. So we're going down a bit, testing again. We hear nothing, so we're going up. This is now the massively blasting signal. Modulating. And you know, it's just a zero. So that's a zero at the volume control. It's always a zero. Always a zero. Switch bands and see if there's a click. There's more than a click. Should we try another band? Could it be a band related thing? Trying to doubt it. Right now we're at 17.5. 17.5. High power. Give it all it's got. 17.5. Nobody home. And I'm sure that's going to be true on all the bands. If we go down, we turn the light out. Light is out most of the time. You don't have to be very precise with this. 3.5. So we'd be at 3.5 megahertz. Why am I doing this? Because otherwise I'm assuming. And nothing to report. 3.5, none of these bands are going to do anything. We're down to the lowest band. I didn't change the tuning here. Okay, we got something happening there. Put this down here. And now the frequency we are on. Oh, I can't even see it. We're not on any frequency. Okay, this is 1 megahertz. So we would be right around 1 megahertz. Nothing. No, we're not going to get anything here. This is not going to work. Okay. Yeah. The question is for me, how much time do I want to spend on this? Because I have the distinct feeling it's not going to get there. Not without hours and hours and hours of effort. I could be wrong. So we could do some basic stuff. Maybe tomorrow that's what I'll do. Clean the switch here, make sure it's in good order. I have had radios with bad switches that you wouldn't think the switch is bad, but in the end a little bit of cleaning and the radio comes to life. So it is possible. Wouldn't bet on it though. Very consistent operation in this switch. Okay, that's it for today. So I wish I could tell you, just hang in with me and this thing will be working like a charm, but I don't think I can make that claim at all with this radio. Yeah. Okay, well, that's it for today. Too bad. Thanks for watching, and tomorrow we'll poke around a little more with it, at least tomorrow. See ya.